Good morning friends. Today in this lecture we obtain Laplacian operator in orthogonal curvilinear coordinate system. The Laplacian operator is denoted by symbol del square. Right? Now the Laplacian operator in Cartesian coordinate system can be written as del square equal to dava 2 by dava x square plus dava 2 by dava y square plus dava 2 by dava z square. Simple. The operator del has the value del equal to I dava dava x plus j dava dava y plus k dava dava z. These I, j, k are the unit vectors in Cartesian coordinate system. Right? Now, here we have to obtain the Laplacian operator in orthogonal curvilinear coordinate system. For that, we consider the del psi. Okay, and this del psi in orthogonal curvilinear coordinate system can be written as E1 cap upon H1 dava psi by dava U1 plus E2 cap upon H2 dava psi by dava U2 plus E3 cap upon H3 dava psi by dava U3. Okay, so this del psi is called as the gradient and it is the vector function. So we write this del psi that is equal to f bar equal to, write this f1 e1 cap plus f2 e2 cap plus f3 e3 cap. Right? Now here f1 f2 f3 are the constant whose value we have obtained in last lecture. That is f1 has value f1 equal to 1 upon h1 dava psi by dava u1, then f2 equal to 1 upon h2 dava psi by dava u2, and this f3 has value 1 upon h3 dava psi by dava u3. Okay, so next we write this del psi. That means we have to write the operator del square. To write this del square psi equal to del 1 dot del 1 psi, that is equal to del 1 dot f bar. Okay, so in last lecture we have obtained the divergence, that is del dot f bar, and this has the value del dot f bar equal to 1 upon h1 h2 h3 in bracket, write this dava dava u1 of f1 h2 h3 then plus dava dava u2 of f2 h1 h3 plus dava dava u3 of f3 h1 h2. Okay, this is the divergence in orthogonal coordinate system. So we substitute the value of f1, f2, f3 in this equation from this equation. That means right here del dot del psi, that is equal to del square psi. So write this term by substituting f1, f2, f3 from this equation. Right here 1 upon h1, h2, h3 in square bracket double u1 of, right, double u1 of the value of f1 is 1 upon h1 double side by double u1, right here 1 upon h1 double side by double u1, then remaining is h2 and h3, right here h2, h3 plus double u2 of, we have substituted the value of f2, and f2 is 1 upon h2 double side by double u2, 1 upon h2 double side by double u2, then write the term h1, h3 plus double u3 of, right here the value of u3, that is 1 upon h3 double side by double u3, right, 1 upon h3 double side by double u3, then next term is h1, h2, complete the square bracket. Okay, so in next step write this del square psi equal to 1 upon h1, h2, h3 in square bracket, right, double u1 of, we take h2, h3 upon h1 double side by double u1 plus double u2 of h1, h3 upon h2 double side by double u2 plus double u3 of h1, h2 upon h3 double side by double u3. Okay, so this is the value of del square psi. Then we have to write the operator del square by ignoring the function psi from this equation. To write operator del square equal to 1 upon h1, h2, h3 in bracket double u1 of h2, h3 upon h1 double u1 plus double u2 of h1, h3 upon h2 double u2 plus double u3 of h1, h2 upon h3 double u3. So this is the value of del square in orthogonal curvilinear coordinate system, right? So this is the operator del square, and it has the value by this showing by this equation. Okay. Then next we take curve of a vector function. Now here we obtain curve in orthogonal coordinate system. Okay, so curve means cross product of vector That means when operator is operated on a vector function with cross product, that gives the curve. So here we consider f(r) is the continuous vector function, and in orthogonal coordinate system it is the function of coordinate u1, u2, u3. So write this f equal to f(r) of u1, u2, u3. Okay, then write this f(r) equal to f1 e1 cap plus f2 e2 cap plus f3 e3 cap. Then we write the curve, that is del bar cross f bar equal to del bar cross in bracket, right, f1 e1 cap plus f2 e2 cap plus f3 e3 cap. So we write separately equal to del cross f1 e1 cap plus del cross f2 e2 cap plus del cross f3 e3 cap, like this. Okay, so this is the equation first, and left hand side is del bar cross f bar. Okay, so first we solve first term of RHS. So take del cross f1 e1 cap equal to, so we substitute the value of unit vector e1 cap, right? So we write here del cross bracket f1 into, we substitute the value of e1 cap, and the value of e1 cap is h1 del u1. Okay, now this value u1 cap, the value of u1 cap we have already obtained in previous lecture, so we directly substitute u1 cap equal to h1 del u1. That means del u1 equal to u1 cap upon h1, right? So write this equation equal to f1 h1 bracket del cross del u1 plus del of f1 h1 cross del u1, right? So is equal to, now there del cross del u1 has the zero value, that means cross product of this is equal to 0. So this term is equal to 0. So write remaining term, that is del of f1 h1 cross del u1. So this is the del bar cross f1 e1 cap equal to del of f1 h1 cross del u1. Then again we substitute the value of del u1, right, equal to del of f1 h1 cross the value of del u1 is u1 cap upon h1. Okay, now in next step we put the value of operator del in orthogonal curvilinear coordinate system, or simply in curvilinear coordinate system. So right here del cross f1 e1 cap equal to, write the value of this del. Del has the value e1 cap upon h1 dabba dabba u1 plus E2 cap upon H2 double double U2 plus E3 cap upon H3 double double U3 bracket complete. Then this is the F1 H1 right here, F1 H1 cross, right, U1 cap upon H1, U1 cap upon H1, right. So in next step, right, del bar cross F1 E1 cap equal to, so here we take the cross product, okay. So E1 cap cross E1 cap, it has the 0 value, right. So write first 0, right. Then E2 cross E1, E2 cross E1 get E3, but it is minus, right here, minus E3 cap. Then this is H1 H2, H1 H2 double double U2 of F1 H1 plus, then we take next up E3 cap cross E1 cap, so right, this is E2 cap, so E2 cap upon H1 H3 double double U3 of F1 H1, okay. So I write this del cross F1 E1 cap equal to, so yeah, I will write positive term first and then negative term. So this is E2 cap upon H1 H3 double double U3 of F1 H1 minus E3 cap upon H1 H2 double double U2 of F1 H1, right. So this is the value of del bar cross F1 E1 cap. Similarly, you can write the next values, right. That means you write the value of this term and this term by comparing, or similarly using this term, right. So in next step, write del cross F2 E2 cap, right here, del cross F2 E2 cap equal to, in bracket I will write E3 cap upon H1 H2 double double U1 of F2 H2 minus U1 cap upon H2 H3 double double U3 of F2 H2, and in next step write del bar cross F3 E3 cap equal to, in bracket U1 cap upon H2 H3 double double U3 of, sorry, double double U2 of F3 H3 minus U2 cap upon H1 H3 double double U1 of F3 H3. Okay, so here we obtained del cross upon E1 cap, del cross F2 E2 cap, and del cross F3 E3 cap. So all these values you substitute in the equation, in this equation. Okay, that is the del bar cross F bar. So write this del bar plus f bar equal to. So we take common. That means we consider this equation, and this equation. Then first we write the unit vector u1 cap. So here is u1 cap and here is u1 cap. So first we write this term and later this term, right? So we'll write here u1 cap upon u1 cap upon h2 s3. Here is u1 cap upon h2 s3. We take common u1 cap upon h2 h3 in bracket. Write u1 u2 of f3 h3 minus, take here u3 of f2 h2 u3 of f2 h2. Okay, then next term we write plus, then we take u2 cap. Here is e2 cap, but it is minus, and here is e2 cap, it is plus. So we take common e2 cap upon h1 h3 and remaining term to write in bracket. So plus e2 cap upon h1 h3 in bracket. Write this term first. Stop. Right, u3 of f1 h1 u3 of f1 h1 minus, here is u2 cap upon h1 h3. So u1 of f3 h3 bracket complete plus. Right, next term, that is for e3 cap. So here is e3 cap and here is e3 cap. Right, so this is the plus term and this is minus term. So I will take e3 cap upon h1 h2 common. e3 cap upon h1 h2 take common. Then u1 of f2 h2 u1 of f2 h2. This is plus and this is minus. u2 of f1 h1 minus u1 of f1 h1 Okay, so here we have written this curl of vector function in this form. So to write this in the determinant form. Now we write the curve in determinant form, and it can be written as del bar plus f bar equal to, right here in determinant form, that is 1 upon h1 h2 h3, right here the term h1 e1 cap, h2 e2 cap, h3 e3 cap, right? Then like this u1 u2 and u3, and next is f1 h1 F2H2 and F3H3. Okay. So this curve of vector function can be written in the determinant form in this way. Okay. So in this lecture I stop here. Have a good day.